For part 3 of this unit, we're going to really focus in on the different parts of an atom. So we know at the center of my atom, I have what we call the nucleus. Now, the nucleus is made up of protons and neutrons. So protons have a mass of 1 AMU. So AMU stands for atomic mass unit. Now, protons have a charge of +1. So think, protons are positive. Now, neutrons are my neutral particle in the nucleus. So neutrons, much like the proton, have a mass of 1 AMU, or atomic mass unit. But neutrons have no charge. They have a charge of 0. So if I have a bunch of positive particles in my nucleus, okay, according to Coulomb's law, we know that opposite charges attract, like charges repel. So how is this atom kept together? Why doesn't it just totally blow apart? Now, we're looking at what holds an atom together. Well, Coulomb's law holds an atom together. Now, the attraction or repulsion depends inversely on distance, okay? So this little diagram right here is just showing you that if I were to spray, say, a wall right here, it's going to cover less area, but more paint. Now, if I spray it a little bit further, my layer of paint is going to be thinner, but I'm going to cover more surface area. Now, really what I want to focus on is the nucleus is held together by what we call the strong force. That's the nuclear force. It's a fundamental force of nature like gravity, okay? And my neutrons also help to stabilize the nucleus by creating space. So if I'm looking at an atom, okay, or my nucleus in particular, I have all of these protons and neutrons at the center of my atom. Obviously, it's much smaller. So I have all these positive parts, but my neutrons are creating space in between my protons, which keeps them further apart, which lessens their repulsion. Now, there's only one element on the periodic table that has an isotope with no neutrons, and that element is hydrogen. So hydrogen has 1 proton in the center and 1 electron around the outside. But how do we figure out how many protons and electrons an atom has? So when we do that, we're looking at what we call the atomic number, okay? So my atomic number is represented by the letter Z, and it tells me the number of protons in my nucleus. So if I'm looking at a periodic table, so helium, for example, has 2 protons in the nucleus. That in this periodic table is in the top corner. So He Z equals 2, which means I have 2 protons. Now, we know overall that atoms are neutral. So if we have 2 positive particles, we must also have the same number of negative particles. So it's also the number of electrons. So helium has an atomic number of 2. It has 2 protons, so He, my atomic number is 2, which means it also has 2 electrons. But our number of neutrons can vary. So just because we have 2 protons doesn't necessarily mean we have 2 neutrons. We can in some examples, but not all. So how do we figure out the number of neutrons? Well, the mass number, which we use the letter A to represent mass number, is the total number of particles in the nucleus. Electrons have a mass that's so small, it's basically 0. So we use E negative to represent electrons. My mass for electrons is really close to 0, so we're just going to call it 0. And my charge of an electron is about -1. So my mass number is my neutrons plus my protons. So I'm going to give you an isotope of carbon. Let's say carbon 14. So this right here tells me my mass number is 14. If I were to find carbon on the periodic table, I would see that my atomic number is 6. That means I have 6 protons and 6 electrons. So if I were to plug this and this into this equation, I have that 14 equals my neutrons plus my protons. So that means for this isotope of carbon, I'm going to have 8 neutrons. Now, I just said the word isotope a few times. Isotopes mean that elements have varying mass numbers because they have different numbers of neutrons. So some elements can have the same number of protons, but different numbers of neutrons. They're always going to have the same atomic number, but they'll have different mass numbers. So in this example above, I did carbon 14, but we could also have carbon 13 or carbon 12. So here, carbon 13, well, my mass number is 13, my atomic number is still 6, my number of protons is still 6, my number of electrons is still 6, but my number of neutrons, well, 13 equals 6 plus neutrons, so for carbon 13, I only have 7 neutrons. Now just to wrap up this section, we have what we call nuclide symbols. Now sometimes you'll see it written like this, where we have an element with the mass number. Okay? Other times we'll see something that looks like this. So my Z is my atomic number. My A is my mass number. And my X is my element symbol. So if I were to write carbon 13, I would put the 13 on top, 6 goes on the bottom, and then I write my C, because that's my element symbol for carbon. I could also have a carbon 14, where I have carbon-14. That can be written as 14 on top, 6 on the bottom, and C for carbon.